Good morning, students. Welcome to the online session of maths class. The first chapter of standard 9th will that's a number system. Now before starting the number system, we have already studied in the previous classes what are a number system. Generally, we know that there is a different form of number systems like natural numbers, whole numbers, integers, rational number, complex numbers, rational numbers, etc., real number, irrational number, etc. So these all are generally considered as a number system. Now number system, first of all we are discussing that natural number is what? What is called natural number? Generally, a natural number which is denoted by n, So n is what? Itself denoted for the natural number, n for the natural number. It's a part of the natural number. So natural number that include all the positive numbers. Like 1, 2, 3, 4, 5, 6 up to infinite. There is no zero included into the natural number, only the positive numbers. So all the positive numbers from 1 to infinite that belongs to the natural number which is denoted for the n. After natural number, there is also a number that is called whole number which is denoted by the w. That is called whole number. It's denoted from the w. That is a whole number. Okay. So whole number is what? Generally, it is like a subset of natural number. Natural number is a part of the subset of whole number because all the members of natural number that belongs to the whole number, but there is also a number 0 which include into the whole number which is not available in natural number. 0 does not belongs to natural number. Okay, but whole number is what? N is a subset of whole number. So whole number is what? 0 as well as all the positive number that belongs into the whole number. Next is called Z. Z is what? Set of integers. Z is what? It is a part of integers. Integers that include 0 as well as positive as well as the negative number. So natural number and whole number is a subset of set of integers. Okay. So all the positive numbers, all the negative numbers as well as the 0 which include into the set of integers. Then it should be next is called rational number. Rational number is what? Always been a form of numerator and denominator, that is upon p upon q form, numerator and denominator form, that is called as a rational number. Now what is called irrational number? Now irrational number, it is only a form of which have not any perfect square, that is called irrational number, like root 2, root 3, root 5, root 7. These all are called as a irrational number which does not having any perfect square. So next is called real number, that is denoted for the r. So all the rational plus irrational, rational plus irrational that belongs to the real number. So all the rational numbers plus irrational number that create the real number. So generally we denote the number system onto the number line, like we have draw the number line. It's like a number line. It should be a point of origin, that is start of O, that is called origin. After that it should be a positive sign. It should be a positive. Okay. And here is part of the negative. Left side it should be denoted as a negative numbers, while the right side that is denoted by the positive numbers, like 1, 2, 3, minus 1, minus 2, minus 3, etc. So all this type of property like sum of numbers, multiplication of numbers or subtraction of numbers, which generally all are the implemented onto the number system by applying these terms. So this is generally part of the number system. So first, just generally clear what is called number system in a form of natural number, whole number, set of integer, complex number, real number, rational number, irrational number. Okay. So now before we starting this chapter on detail, first we discussing about is 0 a rational number. Okay. Is 0 a rational number? Simple thing. Now whatever we are discussing, 0 is rational number or not? First of all we are discussing that. Now rational number is always been a form of what? P by Q form. Rational number is always been a form of P by Q. 1 second. Okay. Rational number is always been a form of P by Q. So is 0 a rational number? Like simple things like 0. 0 is a rational number, like a simple question, is 0 a rational number? Simple question. Now rational number is what? In the previous terms we are discussing about rational number is always been a terms of numerator and denominator, then it should be considered as a rational number. Now we are discussing about 0. Is 0 a rational number? First of all, yes, 0 is a rational number. Simple things, yes. Yes, 0 is considered as a rational number, because whatever you can be added into the numerator as a part of 0, but denominator you can be easily added, like 0 by 1, it should be a rational number, 0 by 2, 0 by 3, etc. Okay. So, yes, 0 is considered as a rational number because whatever you can add into the numerator is a form of 0, but it should be divided by whatever the denominator 1, 2, 3, 4, 5, whatever, it always gives the answer 0. So, 0 is considered as a rational number. Now in the first things, now if I like two numbers and we have to find 6 rational numbers between like 3 and 4, like I write find 6 rational numbers. Simple. One question is that find 6 rational number. Now how we can we find the rational numbers between two numbers, like find 6 rational numbers between 3 and 4. 3 and 4. How we can we find the 6 rational numbers between 3 and 4? Now before to find out any rational numbers between the given number, first of all see there, how many numbers we have to find out? 6 rational numbers. So first of all we have to add another number in how much number we have to find out. First of all we have to find 6 numbers. So 6 plus 1, that is what? 7. Simple. We have to find 6 rational numbers. We have added one number. 6 plus 1 is what? That is considered as a 7. 6 plus 1 is equal to 7. So we have to find numbers, 6 rational number between 3 and 4. So this 3 and 4, that should be individually multiplied as a form of 7 in a form of numerator and denominator. So like 3 and here is 4. Between 3 by 4. Now that is divided by 7, because what? We have to find 6 rational number. We have another one number, 6 plus 1 equal to 7. By default we have to add one number. Now it should be multiplied with the same numbers, like 7 is there, so we have to individually multiply from here 7. Okay, here is also 7. Now into 1 and into 1. Numerator that should be multiplied with the 7, but denominator that can be added in a form of 1, 2, 3, 4, 5, etc. How many numbers you have to find out? Now 3 by 7 is what? 21 upon 7. 4 by 7, 4 into 7, 28 upon 7. Now, so we have two numbers. One is 21 by 7, another is 28 by 7. So all the numbers between 21 by 7 and 28 by 7, that is the between the rational number of 3 and 4. Like see that 21 by 7 first, then 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7 and 28 by 7. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers we have to find out. But we have to only find out 6 rational numbers. So whatever 21 and 28 eliminated. So 22 to 27, these are generally a 6 rational number between 3 and 4. So 22 by 7, 23 by 7, 24 by 7, these are generally considered as 6 rational numbers between 3 and 4. Simple things. So whatever the numbers that should be find out, you have to multiply with additional 1 for this formation, then you can be easily find out form. Like another, we can see it's a part of the integer. Now we will take another example which is having in a rational form. We will take in a form of rational numbers, like we will take 3 by 5 and 4 by 5. Two numbers I will take, 3 by 5 and 4 by 5. 3 by 5 and 4 by 5. How we can be find numbers between 3 by 4 and 5 by 4? I will just find 4 numbers. Just we will take the 5 rational numbers. Okay. Simple, same question. But I will change the question. First 3 and 4 is a part of the integer, but next example it is a part of rational number, that is 3 by 5 and 4 by 5. So in the previous question we have just taken the we have to find out 6 rational numbers between 3 and 4. So that 6 rational number we have add another number 6 plus 1, that is 7. Now in this question we have find 5 rational numbers. So 5 rational numbers we have to find out. So let us take a denominator 5, that should be used plus 1. So let us take denominator. Let us take denominator. Let us take denominator, that is 5 plus 1, because we have to find 5 rational numbers between 3 by 5 and 4 by 5. So we have add one additional 1 number, so 5 plus 1, that should be 6. Now, so 6 is there. So now we have to find 5 rational numbers between 3 by 5 and 4 by 5. So that should be multiplied with the 6 as a form of denominator. So 3 upon 5, one number, another is 4 by 5. And that is multiply with what? Multiply with the 6. Into 6 into 6 is also 6, and here is also 6, right? So 3 by 6, that is 18 upon 5 by 6, 30. 4 by into 6, 24 upon 30. So we have two number, 18 upon 30 and 24 upon 30. So between the numbers of 18 and 24, that is the rational number, like 19 by 30. Okay, 20 by 30, 21 by 30, etc. These all are generally considered as a rational number between the two numbers. Simple. So by using this formula, we can easily find the rational numbers between two numbers. That is already we discussing into the standard 8, right? Now another way simple, like we discussing about more details about rational number or irrational number. Like for example, if every rational number is considered as a whole number, simple one question is that if every rational number is considered as a whole number, yes, true collection of all the whole numbers that contains the natural number. So all the natural number is a whole number, its statement is true, because natural numbers is always the positive numbers, it already include into the whole number. So all the numbers which is include into the natural number, which is available into the whole number, so natural number is considered as a whole number. Okay, simple one discussing is that like every integer is a whole number. Simple thing, integer is what? Integer is generally considered as a negative value. Okay, like plus 1, 0, it should be also considered into integer, as well as minus there, minus 1, minus 2, etc. So is integer as a whole number? Statement is true or false? It's a false. Why? Because integer contain the negative numbers, but whole number doesn't contain the negative value. So integer cannot be considered as a whole number, while natural number is considered as a whole number because all the elements are there. Like another question, if every rational number is considered as a whole number? If every rational number is considered as a whole number? No, because rational number is what? It is always been a form of numerator and denominator, like 1 by 2, 3 by 4, 6 by 8. That is a part of numerator and denominator. It's a part of rational number, but it cannot be included into the whole number, because whole number only contains 0 and positive value. There is no numerator and denominator. So rational number doesn't contain in a form of whole number. Also we are discussing some of the like this type of questions. Every rational number or maybe a irrational number is considered as a real number. So yes, every rational number and irrational number, that is considered as a real number, because all the rational number and irrational number, that is included into the real number. So these are the general circumstances of the natural numbers, whole number, rational number, irrational number, real number, that is included as a part of form. Now we are discussing about that another question is that like square root of all the positive integer is called as a irrational. Like whatever we can see that, like root 3, root 4, root 5, root 6, root 7, root 8. So all the root value is considered as irrational? No, that is false. Like root 4, root 9, root 16, root 25. So whatever the root having a specific values, perfect square root, it always be considered as a rational number. Okay, so every square root doesn't include as a irrational number. So this is a generally bifurcations of the natural numbers or whole numbers or whatever the irrational or rational numbers. Now simple we discussing about if I want to represent any value onto the number line, how can we represent? Okay, let me take another example. Represent 4 by 5 on number line. Okay, if any value we can be represented on the number line easily. So if I want to represent 4 by 5 onto the number line, how we can be represent? See that it should be a line, okay, it should be considered as a number line, where here is OA is a part of the origin number, okay, that is the part of the originated, left side negative number, -1, -2 and -3. Now right hand side, that is 1, 2, 3, 4, okay. 4 is there. Now how 4 is denoted into the different form of 4 by 5. We have to define 4 by 5. So how it can be defined? 5 by 5, that is called as a 1. Okay. 5 by 5, that is what? 4 by 1, 4 by 2, 4 by 3. Okay, 3 we are taking 4 by 5. So 4 by 4, that is called 5. Okay. So 4 by 5 cannot be included here. We can be taken as a 4 by 3, okay. Now 4 by 4, that is called as a 1, so after 4 that becomes as a 5. So how we can be represent 4 by 3 onto the number line like 4 by 3. So that can be easily represented. But if there is a square root value, how can we represent? Like square root 2. We'll take another example, that is simple 4 by 3, it can be easily represented onto the number line. But I want to represent root 2 on a number line, how we can be represent? If I want to represent like root 2, how we can be represent root 2 on a number line? Simple thing, see here, how we can be represent root 2. So first of all, just taking a number line here, okay, here is the 0 originated point, here is the -1, it should be 1, it should be 2. So if I want to represent root 2, there is also a theorem which we have to use here, that is called Pythagoras Theorem. Pythagoras Theorem is always be applicable onto the triangle which have a 90-degree value, okay. So Pythagoras always be applicable onto the 90 degrees angle. So according to that, we have used that hypotenuse square is equal to the adjacent side and opposite side addition squares. That formula we have to use it. So first of all, 0 to 1, that will take 1 unit, that will take 1 unit, and here is another, I will take here B, that is taken as a, that is taken B, that is also taken as a 1 unit. So O to A, that is taken 1 unit, A to B, that is taken 1 unit, okay, both are taken. So here I will write here OA equal to 1 unit, similarly OB equal to 1 unit. Now make a formation of the triangle here, it should be a part of the triangle, so it becomes a 90-degree angle, A becomes a 90-degree angle, okay. So OB square, AB is a 1 unit, my mistake. Now we have to find out the OB, that we have to find out OB. So it is creating a triangle like OAB, that is a part of triangle where A is what? It's a right angle 90-degree. So here we can be used the Pythagoras theorem. So in triangle OAB, angle A is 90-degree. Angle A is 90-degree. So OB becomes hypotenuse, because whatever the side is opposite to the 90-degree angle, it always be a hypotenuse. So using a Pythagoras theorem, OB square equal to OA square plus AB square, right? So OA is what? 1 unit, 1 square plus AB is 1 square, 1 plus 1, that is 2. Now OB square is what? That is 2, but we have to find out the OB. So square is removed from here. So OB becomes square root of 2. So by using their arc, we can create an arc here. That arc is generally a part of the value of root 2. So by using that simple number line system, we can be represent root 2. Okay. So if we are discussing more ahead, we are discussing like decimal expression. Like similarly, you can also represent root 5. More ahead, you can go ahead root 5. Okay. How can we represent root 2? Now we can be connect from here. You can here root 3. You can also take in here. It should be a root 4. Also taking here, it should be a root 5. So that is a root 5. You can also more go ahead. You can be used onto the number line, whatever the number is there, root 5, root 7, whatever. Now how we can be represent a number in a form of decimal? Decimal forms is what, and what kind of say we can be according how we can be represent it onto the expression into the number line. So decimal is what? Decimal representation always be done when the denominator is a form of 2 or 5. Okay? When the denominator is always been a form of 2 or 5, then it can be easily converted into the decimal form. Like I'll write here 4 upon 2. I write here 4 by 2. Now I want to convert into the decimal form. So decimal form, so it should be multiplied with the 5. So 2 is here, that can be multiplied with the 5. So 20 by 10, that is 0.2. Like right here 6 upon 5. So 5 is there, so you can be multiplied with the 2. 12 by 10, it should be 1.2. So you can be easily converted this form of decimal numbers by using a denominator in a form of 2 or 5. So whatever the number in a denominator available, it should be available in a form of 2 or 5. Then you can be easily converted into a decimal form. Like example, 16 upon 25. 25 is a form of 5. Okay. So it should be multiplied with the 4. So 64 upon 100, that is 0.64. So it should be easily converted into the decimal form. Now in the next lecture, we are discussing about how we can be convert the decimal into the rational number, or how we can be converted in a form of irrational number. For today, whatever we are discussing about the natural number, whole number, rational number, real number, irrational number, and how it can be represented onto the number line. When we meet tomorrow, we will discuss about how it can be represented into the rational number as well as irrational number. Okay, thank you.